Hello everybody, I just wanted to put together a couple of these examples where we're literally proving each step of our thought process, which is why it's called Finding Angles with Justification. So this is going to be a little more straightforward example here, but I wanted to just go through the process here. I also wanted to remind you that taking a picture or a screenshot of this and marking up the diagram is a really good idea here. So let's see what they're giving us. So I'm going to head over to a screenshot and just kind of mark up my ideas here. So the first thing I'd like to do is read what they gave us. Okay, that's the most important part, is being able to read the given information and take it from there. So the first thing I'm going to notice is they're giving us a congruence statement, right? Oops. So the congruence statement is telling us that we have a pair of congruent sides. So I'm just going to go mark that first. So BC is congruent to EC. So here's BC, here's EC. So that's going to make this an isosceles triangle. All right, let's keep it going here. From here, they also give us one of these angles here, measure angle ECD, and our goal is to find angle ABE. So where's that? Angle ABE. So that's over here. I'm just going to put a little question mark there. So that's our goal, to find that angle here. So I'm going to kind of talk through my steps here, but I think this is going to be fairly straightforward. I'm going to start from 140 and eventually make my way over to this angle here, ABE. All right, so the first things I'm going to notice here is I have intersecting lines. So I'm thinking I have some possibilities of a linear pair or even vertical angles, but I want to work my way that way. So I'm going to just start off with a linear pair right here. So that's going to be angle what? Angle BCE. I'm going to call it angle BCE. And 180 minus 140 is going to leave me with 40. All right, so I'm going to head over to my actual proof, and I'm going to start to type in my commands. So in this case now, I'm going to say that that angle BCE, I got to use 3 letters here, right? BCE, and that's going to be 40 degrees. And now I got to select my proper reason. So remember, that was a linear pair. So if you look, we have all these choices going down the list here, okay, but I'm going to go with the second one down, linear pair. Now, I'm not going to click anything except the try button on the left, and as you can see, it went through, and they labeled my new angle 40 degrees. All right, so I'm going to go back to the drawing board here. So we now have this as 40 degrees, and remember we said this is an isosceles triangle, right? Right here, boom. So this isosceles triangle has 2 equal sides, therefore we have 2 equal base angles down here. All right, so what I'm going to do here is, I'm going to take this 40 degrees, subtract it from 180, which leaves me with 140 degrees left over, but I have to split it equally between these 2 angles. So I'm going to go ahead and divide by 2. 140 divided by 2 is going to give me 70 and 70. Okay? Now, I'm going to go ahead and put in angle E, just to kind of review a little bit here. I can call that angle E because that's the only angle there, right? It's a lonely angle, plain old angle by itself. I don't need to use 3 letters. Now, my reason is going to be, well, it was an isosceles triangle, so it's not sum of the angles. It's going to be right here, base angles of an isosceles triangle. I'm going to click try. Now, I didn't really need to do that step. I just figured I would just talk about that as review. But I am going to also now go ahead and get angle CBE. You see where I'm looking at? CBE. So now I'm going to say angle CBE is also 70 degrees. Same reason, I'm going to go down to base angles of an isosceles triangle. You now have it. Now I'm almost done here, and I'm going to come over here and say one more time, I have a linear pair, right? Angles that add up to 180 degrees. So I think I'm ready to wrap this thing up here. They wanted angle ABE, and I think we have it, right? So I'm going to type in angle ABE. That is going to be 180 minus 70 is going to leave 110 degrees, and I know that's true because that's a linear pair. So I click try. I'm very happy when they say you're done. Please press submit, and there we go, we get our points. Okay, second example here, a little more straightforward. but also reviewing some things that we haven't talked about from transversals a little while ago. So what I've done is already I've marked my figure with what they've given us. So we have two sets of parallel lines, and then they've also given us a 30-degree angle and a 40-degree angle. So as you can see, we have that marked here, all the given information, and our goal is to find the measure of angle DAB. So where is that? Now here's what I want you to notice here, angle DAB, I'm just going to use a highlighter here. DAB is this whole angle here. So at the end, what we're going to have to do is add these two pieces together to get the measure of angle DAB. Okay, so here's what I wanted to remind you of, and this is a really important idea. So when we have, I'm telling you guys, whenever they give you parallel information, if we have parallel lines, then that opens up the options to use, say, corresponding angles, alternate interior angles, same side exterior angles, things like that. So what I'd like to do is I like to use that capital letter Z just to kind of remind me of where my alternate interior angles are. So if I draw that capital letter Z, it's drawing my attention to like these corners here. Tucked in the corners of that letter Z are my alternate interior angles. So I could actually go ahead and find out that this is 30 degrees right here. Now I can't just call that angle C because there are multiple angles here. So I got to use three letters. So I'm going to call this angle DCA, right? So I'm going to go head over to my proof and I'm going to start to type that in here, right? So the measure of angle DCA is 30 degrees. And then I'm going to choose again for my reasons. Now, if you scroll all the way down, you start to see things like angle bisector. But here we go. Corresponding, alternate interior, alternate exterior, all that stuff here. But I'm going to choose alternate interior. I'm going to click try. And again, as you can see, they did now put my 30-degree angle in there. But I didn't really, I guess that would be an extra step here. I really didn't need that. I actually needed this angle here so I can add these two together and finish my proof. Okay, so I'm actually going to back this up a little bit. Whoops, a little too far. But we did find this to be 30 degrees. I'm going to draw my capital letter Z in a different order here, right? I'm going to actually go here. Check it out. I can actually draw that capital letter Z here. And why is that going to be helpful? Well, if you take a look, this 40 degrees tucked in that corner would also be the same here. So that is going to be called angle DAC. I'm going to head over to my proof. I'm going to type in angle DAC. And that's going to be 40 degrees. And for the same reason, right? I'm going to use alternate interior angles again. Click try. Boom, there it is. And now I want to try to wrap up this proof because I think I am just about done here. Angle DAB is going to be both of these angles here. So this was 40 degrees. I'm adding up both of those angles. So angle DAB is going to be 70 degrees. Now I want you to listen to which reason I choose because some of us haven't used this one yet. So DAB is the sum of 30 plus 40, which is going to be 70 degrees. Now if you notice, I'm going to go all the way down the bottom here. I want you to look at a couple of these choices here. After same side interior angles, we have angle addition postulate and angle subtraction postulate. Since I added two angles together, I'm using angle addition postulate. I click try, they tell me I'm done, submit answer, and we're good to go. Okay, third and final example here. I want to read again through the given information. Now I notice they're also mentioning we have an angle bisector here, right? So, let me go back to where I was. So segment AD gets bisected by angle CAB. So let's figure out where that is. So here it is. Here's AD bisecting, use a highlighter here, angle CAB. So I've already taken the liberty to already kind of take a few steps here. So I noticed if the whole angle was 62 degrees, obviously, if that angle gets bisected, it gets divided into two equal segments. So what I'm going to do is go ahead and get those steps done. If you can see here, I have already done one of them is 31 degrees. I'm going to go ahead and do the other angle above it. So that's going to be angle CAD. So let me go ahead and type that in. So that's going to be CAD is 31 degrees. And my reason is, well, it's an angle bisector. So the only choice in here that has an angle bisector right here is angle bisector definition. So I click try, there we go. I have bisected that angle into 2 equal pieces. All right, so now I'm gonna go back to the drawing board here. And I was able to, if you look up top here, see how it says like, you can hover over to C? When you hover over to C, it basically, look, it gives you the whole angle here. So it's just pretty cool little way to label your angle. So now our goal is to find angle C, right? That's the final angle we're looking for. Now, guys, in this case, there's actually a few different ways you can do this. I noticed that I could use, actually, I could go get, here, let's watch. I could go get this angle here, angle B, because I would know it has 96 degrees and 31 degrees. And I could use the sum of the angles there. But here's what I'm gonna do. I'm gonna use a linear pair here, right? Because I know that 180 minus 96 is gonna leave me with 84. So I'm gonna use that, and then I'm gonna have the remainder of 84 and 31 for my final answer here. So I think I'm gonna go wrap this up here with a few more steps, right? So I'm gonna call this angle CDA. Come on. This is angle CDA, and that's going to be 84 degrees, and that's because that forms a linear pair. Okay, I'm going to give it a shot, try it, it loads up, it's good to go, and now I think I'm ready to finish up here. So I have 2 angles in triangle CAD that are 84 and 31 degrees. So one last time, I have 84 plus 31, that gives me 115. Right? Leaving 65 degrees left over. So now I'm going to finish this up. I can use one letter because there's only one angle at C, and that's going to be 65. And the reason is the sum of the angles in a triangle add up to 180 degrees. I'm going to click submit. We get our points, and that's a wrap. So good luck, guys. Please come see me. Let me know if you have any questions. Don't forget, though, you can also watch a helpful video. You could also go ahead and check show examples.